In this video, we'll do the pre-lab for lab 4, which in your lab book is called You Seem So Distant, using regression for prediction. In this lab, we've actually adjusted the lab or changed it so that it is slightly different from the actual lab that is in your lab book. I do recommend that you read pages 25 through 27 of your lab book so that you can have details on the original lab. And basically, the main difference between what we're going to do and what is in your lab book is the fact that what we normally do in this lab is we'll go to the horseshoe. We'll stand at a central location in the horseshoe, and we'll pick out some landmarks on the horseshoe for you to guess the distance. We'll measure the distance after everyone has made their guesses, and then we'll come together as a class and do some data analysis. Since we can't all be together, what we would normally do, or if we had some inclement weather, we've adjusted the lab so that you could guess some weights of some objects. But now that this is completely online, all of the data collection has been done for us. But what we're going to do is we're going to give you an example of a student guessing weights of objects and then using some statistical analysis to see if we could predict the weight of an object using predict the true weight of an object using the guessed weights that we use. And so, again, we're going to use correlation to measure the relationship between two quantitative variables. These quantitative variables are the guessed weights and the true weights. All right, weights are quantitative variables, so we'll use correlation to measure those relationships, and we'll use regression to make predictions. And we're going to specifically look at simple linear regression. And so what I want to do is review some of the concepts that we'll use from lecture. We may not get to all of these concepts, which is why this video is important. But two of the concepts, or one of the concepts, has to do with the variables. When we use regression, usually it is obvious that one variable is going to explain or explain the other variable. The explanatory variable, I'm going to start with that. In math, we call that the independent, math and science, we call that the independent variable. But in statistics, we sometimes call that the explanatory variable. This is the variable that explains the other variable. And that other variable that is being explained is called your response variable and is given by the variable y. Okay, so the response variable is actually the variable that we usually want to make a prediction for. And so I want to predict something that is going to be my outcome or my response variable. And the thing that I'm using to make that prediction is my explanatory variable. A scatter plot is basically a plot of a bunch of ordered pairs, like if you think mathematically. And so it's a graphical display that's used to, and I'm sorry that this picture is in your way, but it's a graphical display that's used to show the relationship between two quantitative variables. Once we get a scatter plot, we can kind of get the relationship, and we have an index to measure the relationship between two quantitative variables, and it's called correlation. A correlation coefficient is a descriptive statistic that's used to specifically measure the linear relationship between two quantitative variables. And so we're interested here with a correlation coefficient and a linear relationship, a relationship that makes a line between the two variables. Our correlation coefficient is usually given by the variable r. It ranges in value between the numbers -1 and 1. The closer that value is to 1 or -1, the stronger or more linear that relationship is. And the closer that value is to 0, the weaker that relationship is, that linear relationship is. Some guidelines that have been used to measure or put words to the actual values of the correlation coefficient. If the absolute value of that correlation coefficient is greater than or equal to 0.7, that's a strong linear relationship or a strong correlation. And if it's smaller than 0.4, we usually call that a weak correlation. Simple linear regression. This is the statistical analysis that involves creating a line of best fit that can be used to predict the values of your response variable using some values of your explanatory variable. This method or this tool, the statistical analysis tool, is only appropriate when you have two quantitative variables with a strong linear relationship. And we just got finished saying that the correlation coefficient measures the strength of your linear relationship, and we said that 0.7, the absolute value of R was greater than 0.7, then we have a strong linear relationship. So if we see a correlation coefficient of 0.7 or greater in absolute value, then we can go to the next step to use simple linear regression in order to come up with the line of best fit that can be used to predict your outcome or your response variable using your explanatory variable. A regression line is given by y hat. We use that y with a little caret symbol on top or a hat symbol on top. And it's a linear equation, right? And so a lot of people remember y equals mx plus b. Well, for us, we're going to write our linear equations as y hat, which that y hat represents the predicted response, and it equals a plus bx. So remember, y equals mx plus b. M was your slope. The thing that's multiplied by your input variable in math is called your slope. And so here I have b multiplied by my explanatory or my input variable. And it basically can be interpreted as the increase if it's positive or decrease if it's negative in your predicted response for a 1 unit increase in your explanatory variable. So it tells you how much your output or your y increases or decreases when you increase x by 1. That's your slope. You also have a vertical intercept, which a lot of people in math call your y-intercept. That gives the value, that is a in this formula, and it gives the value of your response when the explanatory variable equals 0. And so you want to be able to interpret this in the context of this problem here. Just so you know, our explanatory variable, since we want to predict true weights, then our explanatory variable is going to be the guessed weights, and then our response variable is going to be the true weights of the objects that are measured. Another concept is residual. The residual is basically the difference between an observation, so a real observation in your data set, and a predicted value of your response variable, right? And so since I know we've been using X to represent observations, but since we have two variables, we have X and Y. And so an observation on your response variable is just given by Y. And so this Y here represents an observation in your real data set. So Y is an output, which is the output is your true weight, minus your predicted true weight. That's going to be your y hat. The y minus y hat is your residual. You got your observed data, what you observe empirically, and this is coming from your predicted y value or your true weight, right? So your observed true weight versus the predicted one, the one that's predicted from the model. And basically a residual can be used to kind of gauge how far off an observation is from what is predicted by the line of best fit. And so those are all the concepts that you're going to use in this lab. It's a quick summary. And so the plan for this lab, again, our goal is to determine the guessed weight, if guessed weight can be used to determine or estimate true weight. And so I'm gonna give you a bunch of data. You're gonna use StatCrunch in order to help you do this. I'll create a video that'll walk you through the process of creating a scatter plot, running a correlation analysis to determine the correlation and the strength of that linear relationship. And then we're going to run a regression line so that we can obtain the line of best fit, and we'll use that to calculate a residual. And so what you want to do now is you want to finish pre-lab 4 assignment, so answer the questions that are in your pre-lab assignment, and then you're going to complete the lab 4 assignment, which is posted in the lab 4 folder in Blackboard. In that document, it'll take you or walk you through some steps that'll help you complete the lab.